bounded by the curve, and the axis, and we did area bounded by two curves. And today it is chapter 16, kinematics. The main theme is that we'll have distance or displacement, displacement time graph, velocity time graph, acceleration time graph, or equations. So differentiation of displacement will give us velocity. Differentiation of velocity will give us acceleration. So dy by dt. And integration of acceleration will give velocity. And integration of velocity will give displacement. So if we are moving up from this graph, we do integration. And if we are moving down, we do differentiation.
So basically, integration of acceleration is velocity, and integration of velocity is displacement.
Yes.
And then the displacement to velocity is
Differentiation of displacement will give you
velocity, and then this differentiation of velocity is acceleration. But then
yes,
if we accelerate, like acceleration to displacement is also integration?
two times.
Oh, two times.
You'll
Okay.
integrate it once, you'll get velocity, and then integrate again, then you will get displacement.
And it's the same for displacement to acceleration, right? Two
Yes.
times
Step by
displacement.
step. Yes.
Yeah. Two times differentiation. Okay.
Now, basics prerequisites of kinematics is just like basic physics. Okay. Calculate the speed time. Calculate speed from a distance time graph. So we are talking about the first one. From distance time graph, we differentiate to get the velocity. So if I'm looking at the graph, see I'm covering 50 meters in 40 seconds. So speed is distance over time. 50 divided by 40. So if you see gradient of this first half is also gradient of this part is y over x is 50 over 40. Calculate the speed of the swimmer for the second length. So second length again, distance covered is 50 and time taken is 35. That's again gradient. If you're talking about speed time graph in the second example, it says calculate the acceleration. And see speed time graph, the differentiation of speed time graph is giving us the acceleration. So acceleration in the first half is 15 over 20. The acceleration in the second part is 0 because the gradient is 0. It is horizontal. Acceleration in the last part is 15 divided by 40. That is half of acceleration. See, it is showing same change in speed but in double time. The first is 15 by 20, that is 0.75. Next is 15 by 40, that is 0. Using calculator. 0.0, 0.375, half of 0.75. So applications, displacement time. We are going to get velocity by differentiating it. In all the applications, if you would remember when we used to differentiate, if let's say this is S, it is denoted by S. S is against time. So displacement time graph. So ds over dt. First of all, it is giving me velocity. And remember, we used to put dy by dx or dx over dt is equal to 0 when we wanted the turning point. So see, dy by dx, this is the turning point. So we put that equal to 0 because when gradient is 0, at that point you'll get time, that is 2 in this case. So you can put 2 in the equation and get the exact value of displacement, which it was at the turning point.
Wait, I don't fully understand.
If I just tell you to find the turning point, so this is the equation s is equals to 4t minus t square ds over dt. Turning point at turning point gradient is 0, so this is 4 minus 2t. 0 is equals to 4 minus 2t. 2t is equals to 4, t is equals to 2. Are we getting it? Exactly on the turning point because
Yes.
we substituted 0. Gradient at the turning point is 0. So you already have it either from graph or by the equation. Mostly this is an example. This is to explain. That's why both are given, or else only equation will be there. And similarly, because we have the equation of displacement, so we can find the displacement at any point. If you just substitute 1, you'll get 3. If you substitute 4, you'll get 0. And if someone is asking to find the distance traveled in first 5 seconds, so we know that the object is turning at time 2. So at time 0, it was at position 0. At time 2, it is at position 4. Then at time 5, it is at position minus 5. So it just came here. That means the object was going there and then came back. So that means 4, this is 4 and 1. So total 9 meters. Object has traveled 9 meters. Displacement is minus 1.
It
But
started at 4, and then at the turning point, it was also at 4.
mm, see, at time 0, it is at 0.
Yes.
At time 2, it is at 4.
Yes, in the y axis. Yeah.
Yeah. So at till time 2, it has traveled 4 meters already. At time 4 again, when time is 4, the displacement is 0. So that means it is at the starting point. And when we substitute 5, and we're getting minus 5. So it is traveling. Negative means displacement is in opposite direction. So total distance is 4 meter plus 4 meter plus 5 meter. 4 plus 4 plus 5 is 14 meters is the total distance, and final displacement is definitely minus 5. Distance covered during the journey
Wait,
is 40.
so we first counted the y axis and then we counted the x axis?
Now only y. See, at time t is equal to 0, the particle is at the starting point, t0 at origin, and at time 2 seconds, it is 4 meters from the origin. Then at time 4, it is again at the origin. Till now, it has covered 8 meters. Displacement is 0, but the distance covered is 8.
Okay.
And at time minus 5, time at time 5, displacement is minus 5. So it is covering another 5 meters, but in the opposite direction. So where is the total distance is sum of the individual displacements. Displacement at time 4 is 0, but distance covered is 8. If someone starts from this point P,
Wait, I
moves,
understand the 4 and the 4, and then time equals again to 4, and we'll make it 0. But then the extra 5, or
where is
negative
the particle when time is 5?
It's at 0 again.
Now, at time 5, at time
It
5,
was below 0.
yeah, it is at position -5. So either you find that from the graph, in this case, graph is given, so I can tell that at -5, the displacement is -5. If the graph was not there, I'll substitute the time in the given equation. That is, displacement is 4 into 5 minus 5 square. That will be -5. That's how I'll know where the particle is at a time 5. So the particle is at -5 already. So total distance is, when it started from O, it moved away 4 meters, then it came back again 4 meters, and then another 5 meters in the same direction. So
Okay.
total is 14 meters. Difference of distance and displacement. If the particle travels in different orientations, we just keep on adding every distance. This is the total distance, and if it is ending at P again, the displacement is 0. The velocity time graph is the gradient. Displacement is already given, and single derivative will give you velocity, and differentiating it again will give you acceleration. Okay, last discussion. What does this say? Earlier in the chapter, we discussed considering the displacement time graph for the first 5 seconds of the motion of the particle. The displacement of the particle s meters from fixed point t seconds after passing through O was given by s is equals to 4t minus t square. Equation is given, graph is done. Working in small groups, complete the following tasks. Find the expression in terms of t for the velocity. So we already know that displacement is equal to 4t minus t square. So, so the velocity is differentiation. The ds over dt is actually velocity. The differentiation of 4t is 4 minus 2t. This is the differentiation. Find expression in terms of t for the velocity of the particle. Then draw the graph of velocity for 0 to 5. Now I have that equation from 0 to 5. I'm substituting time 0 and plotting those points. When t is 0, v is 4. When t is 1, 4 minus 2 is 2. When t is 2, v is 0. At 3, at 4, at 5. And this is actually a straight line with gradient -2. Okay. Then it says state the value of t for which v is positive. Because we've drawn the graph already, so we can tell when t is less than 2, it is positive. For t less than 2, it is positive. When it is 0, at t is equal to 2, velocity is 0. And when is it negative? When time is greater than 2, the velocity is negative. Fourth part says, what can
Wait,
you
when
say?
time is greater than 2, velocity is negative?
Yeah, see, at time 2, the graph actually crosses the x-axis and is on the negative side.
But that's smaller than 2, right?
Greater than 2. This is 3, 4, 5. X, value of x, value of time. When the value of time is 2, 3, 4, 5, at that point, graph is below. At that point, velocity is negative.
And that's below 2, right?
This is time axis, which is on x-axis. At time 0, velocity is 4, positive. At time 1, velocity is 2, positive. At time 2, velocity is 0. Velocity is equal to 0. But at time 3, velocity is negative. At time 4, velocity is negative. At time 5, velocity is negative. Whatever the value is, but it is negative. So it is negative after passing time 2. When is the velocity negative? When time is more than 2. At time 2, velocity is 0. At time more than 2, it is negative.
Oh, I understand. So after the value of the x, then it would start to be negative.
Yes.
For the velocity, the way that we wrote it for velocity, right?
Yes.
The linear graph.
Yes.
Okay.
What can you say about the direction of motion of the particle when velocity is positive? So when velocity is positive, it is moving in one direction. I would say away from the origin. When it is 0, it stopped. Does that make sense? Velocity is 0, car is at rest,
Yes.
is
Yeah.
not moving. And when it is negative, it is actually coming back or in opposite direction. Because normally we say that car is moving with 5 meters per second in this direction, and minus 5 would mean reverse. Just like vectors. Velocity is a vector quantity. So if that was towards north, now it is towards south. Find the acceleration of the particle and interpret your answer. Now discuss your okay. For acceleration, we need to go for another differentiation. So dv over dt is acceleration. Another differentiation 4 goes away. This is minus 2. So in this case, acceleration is only minus 2 irrespective of time. And we can see that it is no more a curve. That's a linear equation. That's a straight line. And gradient is already minus 2. So acceleration is minus 2 throughout. And throughout, negative acceleration means the velocity is actually decreasing. Worked example. A particle moves in a straight line so that t seconds after passing the fixed point O, its displacement from O is given by this equation. Displacement is given. The first question is find the velocity. So what do we need to memorize is this. Displacement time, velocity time, acceleration time. Moving down is d over dt. Moving up is integration. So the equation, the first equation is given, that is of displacement. Displacement equals t cube minus 12t square plus 45t. And the first question asked is for velocity. So for velocity, we need to differentiate ds over dt. This is 3t square minus 24t plus 45. So the velocity at time t is equal to 2. 3 into 2 square minus 24 into 2 plus 45. It simplifies to 9 meters per second. Then we have find the acceleration at t is equal to 4. So we already know we have to memorize this. Displacement, differentiation of displacement is giving me velocity. The equation is right in front of me. Another gradient, another derivative will give me acceleration. So velocity is already there. Acceleration is dv over dt. I'm looking at this equation and derivating it. So differentiation of 3t square is 6t and then minus 24. And the question was find the acceleration when t is equal to 24. T is equal to 4. So 6 4 times 24 minus 24 is equal to 0. At time 4, acceleration is 0. C part
So
says
the actual units for each of them, because in the answer it says 9 meters per second to the power of negative 1, and then for acceleration it says 0 meters per second to the power of negative 2.
0 meter per second square. Yes.
Do we have to put negative 2 or can we just put squared?
That's just writing style. If you write it like this way, that is meter per second square, or you take that as a numerator. And these are just writing styles. All three are same.
M over S squared is the displacement.
Acceleration. All three are same for acceleration.
And for displacement and for...
No, no, no. For displacement, displacement is distance, that is meter. Velocity is speed, that is meter per second. And acceleration is meter per second square.
Okay.
Okay. C part says find the displacement of particle when from O when t is 7. So displacement, we have the equation. C part says find the displacement. Displacement is t cube minus 12t square plus 45t. So what is the displacement when particle of the particle at time 7? I'm using calculator. So that's 7 cube minus 12 into 7 square plus 45 into 7, and I'm getting positive 70. Displacement is 70 meters at that time. Find the displacement of particle from origin when t is 7. I missed C part. I did D part. Okay, this is D. Already done. That's 70. What is C part? It says find the value of t when the particle is instantaneously at rest. At rest would mean velocity is 0. Do you agree? At rest is velocity is equal to 0.
Yes. Because
So
then
when
there's
is the
no
velocity
motion.
0? We have the equation already, this one at the top. 3t square minus 24 plus 45. 3t square minus 24 minus 24t plus 45. This is the equation of velocity for part C. So 0 is equal to 3t square minus 24t plus 45. Find the value of t. Can you do that?
Okay. So we just find T from T 3T
From this
squared
quadratic.
minus... Yeah, okay. T equals 3 and T equals 5.
3 and 5 years. We already did the D part. Displacement at time 7. Now it says find the total distance. Now we have to understand one thing. Let's say this is the mean position. This is the origin. So at time t is equal to 0, it is at, at mean position. And you just found out t is equal to 3 and 5. And 3 and 5, the particle is at rest. That means the particle is changing direction at time 3 and 5. See, your car is moving in one direction. It is moving away from the house. And when it stops, then it comes back. And it stops again. Then it goes back. You cannot change direction until it stops. If you're moving in one direction, to go in reverse, it has to bring its speed to zero and then go back either on the same road or going reverse direction. Hitting it, it is in the straight line. It is moving in the straight line, but we don't draw it like that because we won't be able to see it. We just draw it like this, but it is moving in straight line. So at time t is equal to 0, we know it is at rest. So I need to know at time 3, at time 5, we've already done for time 7. Displacement at that point is 70 meters. Find the displacement at time 3 and 5, and equation of displacement is there for 3 and 5.
Four, three, and five?
Displacement for time 3 and time 5.
Oh, okay.
We have to time substitute the time in displacement equation.
So the three and the five in the, so we already have the velocity equation and O is the displacement equation, right?
We are looking for
Zero.
it is given in the question.
Oh, S equals T cubed minus 12T
Yes.
squared plus 45T.
Yes.
Okay. For three, it should be 54. So, no, it should be, yeah, 54 meters.
P cube
And
minus
then,
12 into 3 square plus 45 into 3. Yes, 54. And then for pi,
then for five, it should be 50. And then we would subtract the 54 and the 50 to get the 4.
no, we don't need that. I'm just quickly rechecking for 5. That's 50. At time 5, displacement is 50. And at time 7, displacement is 70. We already did that. Now E part says find the total distance traveled in first 7 seconds.
Wait, so then we add the 54, the 4, the 54, the 50, and the 20?
I'll show you. At time 0, it is at 0. Agreed?
Yes.
This is the timeline. Let's say that's 1, that's 2. We are least bothered about 1. We are just bothered about where it stops. So we will discuss at 3 and then time 5 and then time 7 and so on. So the particle is moving away from mean position in the first 3 seconds. It is 54 meters away and time is 3. But what happens at time 3? It stops and it reverses its direction, and see at time 5 it is actually at 50-meter mark where time is 5. Then it again stops and changes direction, and at 7 it is at 70-meter mark. So basically the particle first covered a distance of 54 in time 0 to 3. Then the particle covered a distance of 4 from time 3 to 5, and then from time 5 to 70, 50 to 70. In the remaining time it covered a distance of 20. So it covered a distance of 78 meters in this journey.
So total of 78, right? 78 meters?
Total distance of 78, yes.
Because we first did the 54 and then the 4 because it was the 54 minus the 50, right?
4 going back.
Because it's going back. And then going forward again, so that was another 54.
From 50 to 70, another 20.
Wait, 50 to 70, another 20.
Yeah, it is no
Oh,
more at
I understand. Okay. So that's the 20, and then, but it's still, isn't it still 54 meters?
it already went back to 50 from time 3 to time 5.
Okay.
So the distance covered is now 78. If at any time it is on origin, displacement will be 0, but definitely it has been through some distance, right?
Yes.
So distance part is something else and displacement part is something else.
Okay.
Try this question. How far have you done it?
I was just still working up like the thinking part of it, but I'm about to finish.
The
Cause it's
particle moves in
long.
a straight line
Yeah.
so that the displacement from fixed point is O. Displacement equation is already given, so no thinking part at this point. When t, where t is this time in seconds after passing O, it says find OX.
Then that would just be ln5 because when it passes the line, passing the point on x would be the 0, and then it would just use the displaced version
Yes.
of the actual one, so it'd just be the ln5.
Distance is from position O. So this is worked example 2. So let's say this is O and OX is the distance where t is the time in seconds after passing point x. After passing point x, not O. So the particle is moving, it crossed O, but then it crossed x. Their time starts. So x is how much meters away? Displacement is ln 2 into 0 plus 5. So this is ln 5. ln 5 is 1.61. So it is 1.61 meters away from the origin.
Okay.
Then it says find the velocity when t is 10. Now displacement velocity. From displacement is already ln 2t plus 5. So velocity is actually differentiation of displacement. So we differentiate it. This is 1 over 2t plus 5 into 2, 2 over 2t plus 5. So it says find the velocity when t is 10. So at time 10, 2 into 10 is 20 plus 5 is 25, 2 over 25. I'm seeing if I get exact answer in decimals. 2 divided by 25 is 0.08. So at time 10, velocity is 0.08 meters per second. C part says find the distance traveled during the third second. Distance during the third second. So we don't know where is it going. It is going in positive direction or negative. It is changing direction or not.
But since
So
it's distance, we don't need to know, right?
so yeah. So at time t is equal to 2, I need to know that. At time t is equal to 3, I need to know that. So distance traveled in the third second. Wherever it is at 2, wherever it is at 3, I'll find that distance. But I do need to know if it is changing direction between 2 and 3 or not. If it is not changing direction, then no issues. It is in one direction. So velocity, I'm substituting velocity is equal to 0 to see if it is changing direction at any time or not. So velocity is already there. We differentiated it. Equation of velocity is this. So if I substitute it equal to 0, I'm not getting any time. So it is actually not changing any direction. So clearly at time 2 and at time 3, I need to know the distance traveled. So displacement when time is 2 is ln 9, and displacement when time is 3 is ln 11. So distance traveled in the third second is ln 11 minus ln 9, and that is ln 11 minus ln 9 is 0.2006. So I'll just write 0.2 meters. C part is 0.2. Yeah, I was getting 0.200670, 0.201 meters. D part. Find the acceleration of the particle when t is 2.5. So acceleration is again this derivative of displacement, derivative of velocity. So this was displacement time, velocity time, and then acceleration time. So equation of acceleration is there, and we are derivating it 2 over 2t plus 5. Velocity is 2 over 2t plus 5. Velocity is 2 into 2t plus 5 minus 1. And acceleration is differentiation of velocity, that is minus 2, 2t plus 5 minus 2. 2t plus 5 whole square. And when did we want that? When the acceleration of the particle when time is 2.5. So 2 into 2.5 plus 5 squared. 2 into 2.5 is 5, 5 plus 5 is 10, 10 square is 100. So this is negative 0.02 meters per second square at time 2.5. Acceleration is negative 0.02. Why am I getting 4? Oh, yeah, yeah. This was power done and I forgot the base. That is 2 into 2. This is 4, 4, 4. Negative 0.04 meters per second square. Do you understand where this 2 is coming from? When we differentiate, I forgot that 2. Velocity was 2 into 2t plus 5 power minus 1. Acceleration is differentiation of velocity, so power comes down, gets multiplied. 2t plus 5 power minus 1. And then we multiply with differentiation of what is inside. I got minus 4 over 2t plus 5 whole square. And we end at negative 0.04 meters per second square. Look at this third example. Any issues till the second one? Are you there?